Hello and welcome to the sixth lecture in our comprehensive course on AI, ML and DS. We are at present in chapter 22, and in chapter 22 we are doing this part C, introduction to the feature selection methods. Right now here we want to talk about three main categories of methods. Some are called filter methods, some are called wrapper methods, and some are called embedded methods. In filter methods there are many examples. Here these are the examples, and we will do first this as the initially we will discuss this in this lecture. Similarly, in the wrapper method, there are many examples. RFE, that is recursive feature elimination, FFS, forward feature selection, BFS, backward feature selection. So among that, we will do the first one. In embedded methods also, there are several techniques. This is LASSOCV, feature importance with random forest, feature importance with XGBoost, and so on. Now, we will here also do only this one. Then the question would be, what about the next methods? So next methods we will be discussing each of these, but that we will be discussing in the subsequent lectures. But in this lecture we will do one example of filter method, one example of wrapper method, and one example of this embedded method, right? Okay, fine. Now first, why feature selection is done and what is feature selection? So suppose I have this kind of machine learning model. Say y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Forget about this red portion in the bottom, just only this much portion you have to focus at present. That is this portion. Okay. So this is a model in which this y is called response variable, and this x1, x2 and x3, these are called three features. Right. Now we know that it can be any number of features. It can be 10 features also, or it can be 20 features also. And accordingly there will be many coefficients. While this is called intercept will be 1 only. So beta 1 x1 plus beta 2 x2 plus and so on up to beta 3 x3, and beta 4 x4 plus beta 5 x5 plus beta 6 x6 and so on. Now the question is that when you make a model, sometimes the model becomes so complex that it starts overfitting. Means it will give very good accuracy on training data, but it will not give good accuracy on test data. And in that case, we try to simplify the model. Simplify the model means out of all these say three features, you will try that suppose this x1 and this x2, they are the only features which are more important for predicting y, while x3 has not much of a role in predicting y. So we will do a simple model in which this third term will not be there. So y is equal to beta 0 plus beta 1 x1 plus beta 2 x2. Then this whole process which I described, that x3 is not important and therefore its coefficient is very small, so x3 is not important and all that, that is itself called feature selection. Now what are the benefits of this? Then the benefits are obviously that more relevant features are selected and irrelevant features are removed. Okay, and as a result, those features which contribute the most to the prediction variable y, that are only kept. This improves model performance by reducing overfitting, and training time is also reduced. Actually, this is the most important thing, that when you reduce the features, then model's complexity decreases. So the direct effect of reducing features is this, and this further leads to two effects, that when complexity decreases, then overfitting reduces and generalizability increases. Also, training time reduces. Because here we took still a very simplified example in which there are only three features, but sometimes there can be a data set in which beta 1, beta 2 and so many x1, x2, x3, x4, x5 up to x50 columns are there. So the response variable may be dependent on 50 different features or columns, right? So in that case, if you try to make a model with all 50 features, it would be very complicated, and it would make the model, it is highly likely that the model will overfit, right? Okay. Now, so you would like to select certain features which are the most important, and you will like to ignore certain features which are irrelevant. But the question is how to identify which are important and which are not important. Then for that only there are three categories of method: filter methods, wrapper methods, and embedded methods. Now let us start filter method. These are the names as I said, but we will do only the first one, k best features, right? So in the k best features method, this is the way in which we will do entire discussion in this part with our California housing data set only. So from sklearn.datasets import fetch California housing, right? There are many more data sets also. For example, after this import you leave a space and press tab character, then you can say that fetch 20 news group, fetch California housing, fetch KDD cup, LFW pairs, and so many, fetch OpenML and SVM and wine data set and blobs, make blobs, and so many different tools are there. But here I want to fetch California housing. So I just write FET and it will automatically put this fetch California housing. Now this is my data, and I just print the top 5 rows. This we have done so many times that I'm not bothering to discuss what is this. Okay. Now we divide this into X and Y. Now one important thing is, where is Y here? Because so far in our discussion, we have never specified actually which is the response variable out of these columns. The reason is that when you take this data is equal to fetch underscore California underscore housing, you will see that that data thing is actually slightly complex. It is not pandas data frame, but it is one this kind of output. So it is an array, and in which this is target variable here, and this is target name is median house value. So if you see that column, you will not find, is there any median house value here? No, right? So that means this is all features, and that also you can see when you see the output of that data, that this is feature names, median income and house age starting up to latitude and longitude. So these are all actually just features. So where is my response variable, target variable? If you want to find, then for that you have to do one more thing, that is data dot target. I at least now know what is the name of my target variable, that from the output of data it is median house value, but what are the values? So then these are the values of my target variable. Here also you can see, or here you can see, right? So these are the values of median house value, that is target variable. So now so far whatever we are printing top 5 rows, these are only the features. So that means they are in this they are only this x1, x2, x3 up to x8. There are 8 columns. And where is my y? So that y is DF5 median house value. And even for the features, I don't want all the features at present, all 8, just for the sake of simplicity. So I'm taking only 3 features. So I'm taking a subset of this data set, and in which only 3 columns are there. And that means I'm dropping these columns. Okay, just randomly. So far there is no feature selection, or there is no logic explained why we are dropping it. That logic and etc. will come later on. But just we are dropping a few and keeping the 3 only. And x and y are separated. That is, now these are my features column, x1, x2, x3, and y is my target variable. So this now it looks like more like this equation, right? That beta 0 plus beta 1 x1, and x1 is median income, x2 is house age, and x3 is average rooms. So let us print what are my x and y just for the sake of visibility proper. So this is my x feature matrix. It is 3 columns and all 20,000 rows, right? And this is my print output of print y is here. That is my target variable value in the form of an array. Now let us use first feature selection technique. So first of all, we are at present discussing filter methods, and in filter method also we are discussing only k-based features. So let us do that. So from sklearn.feature selection, import select k-based and F classification. Now again here also there is no need to remember. If you know that you are asked to do k-based feature, then select import and press tab character. So then you will see that k-based feature would be there somewhere, and F classification is definitely there. So k-based also will be there somewhere. Let me press K so that yeah, select k-based. Okay, so then you have imported those 2 things, right? Thereafter you are creating a selector object using that select k-based, in which core function is F classification and k is equal to 2. What is the meaning of this core function? Here if you read about filter methods, then it is clearly says that this method applies statistical measure for scoring each feature. That is, out of these 3 also I want to find what are the top 2 features. Okay, so I have already taken a subset of my original data set, and now my x is only having 3 columns, and my y is having this response variable, and I am trying to find out of these 3 also what are the 2 most important features. So is it clear what problem we are trying to solve? Right. Now then for that we are using certain score functions. Score functions are nothing but some statistical method, maybe chi-square test or NOVF test or correlation coefficient test or all. That is the reason of doing all those tests in so much detail in previous chapters, because otherwise you will mechanically do this, but you will never understand that when you are using this F classification or select k-based. Suppose you are asked in a job interview, underlying to this which methods are there, then you will have to say that the methods are that is the statistical methods like ANOVA or chi-square test or that correlation coefficient test, etc. But this automatically performs those tests and directly gives select k-based, where k you have to specify. So I have 3 features and I want to select 2 best features out of this. So first I create a selector object using this score function. My selector object will select this many features, right? Okay, and then selector.fit underscore transform x comma y. X is what? My feature matrix, and y is what? My target vector. So if I do this, then I print what are the selected features. So I get that out of the 3 features which I chose here, median income and house age, they seem to be the most important features for deciding the y. Y is what? The median house value. So that means I can drop these average rooms, or in other words, in that model, beta 0 plus beta 1 x1 plus beta 2 x2 beta 3 x3, I can safely remove this third term, and only x1 and x2, that is median income and house age, can be taken according to this first method, that is select k best, that method, right? Okay. Now second category of method, that is called wrapper method. Here also there are multiple examples, RFE, FFS and DFS, but we will talk about only RFE. Now what is the difference between wrapper method and the earlier done filter method? Filter method use statistical tests to decide best features, while wrapper method actually create models. So wrapper method consider the selection of set of features as the search problem, and different combinations are prepared, evaluated and compared to other combinations. Then a predictive model is created which combines, tries different combination of features and find the accuracy of the model, and whichever combination gives the best accuracy, that feature is used. Now what is the meaning? Say here I take this example only once again. For example, again California housing data set, and this is the head top 5 rows. So these are my total 8 features. Again I am, for simplicity, taking only 3 features. Remember here there is no feature selection technique that I have used. I am just randomly taking 3 features. I could have taken all also, it would not make any difference, but I am taking 3 features just to make calculation faster and just to make my discussion easier to follow. Okay, so that 3 features I am taking, and this is my response variable median house value, and if I print x, then this is my reduced feature matrix, 3 features. Now I want to find, suppose again, 2 best features which are the most effective in deciding the value of y, that is median house value. Okay, and for that, this time I don't want to use filter method, that is I don't want to decide it statistically by scoring function like f score and all that. Instead, here we use that only, score function is equal to f classification, and the method used was select k best. That I don't want to use. Instead, I want to try every subset of the columns and make a regression model for predicting my this response variable. So that every subset means I can try first a regression model with only y and x1. So in that, in this, it would be y is equal to beta 0 plus beta 1 x1. Then I can take only house age. So at that time y is equal to beta 0 plus beta 2 x2, only one term again. Similarly, I can try only average rooms. Then at that time y is equal to beta 0 plus directly the third term beta 3 x3. Then I can try first and second, that is these 2 features as one subset. So y is equal to beta 0 plus beta 1 x1 plus beta 2 x2. Then I can try second and third. So at that time y is equal to beta 0 plus beta 2 x2 plus beta 3 x3. Then I can try first and third feature. So at that time y is equal to beta 0 plus beta 1 x1 plus beta 3 x3. So if I try such every combination and then I decide which feature is which set of features, which subset of features give the best accuracy, then obviously if I get the highest accuracy when I took suppose only this many features, that is these features beta 0 plus beta 1 x1 plus beta 2 x2, then I would say that clearly those 2 features must be the most significant features, right? So that is median income and house age, they should be the most significant features. But suppose this was just an example, suppose I got the highest accuracy by taking this many features in the blue bubble. Okay, so that means beta 2 x2 is not there. So in that case, median income and average rooms, they are the features which give the best possible model, and that means they are the features which are having highest accuracy. So now if you read that sentence, then it will become clear that wrapper methods are unlike filter methods. How they are unlike? Filter method uses some statistical function, scoring function, and select the best features, while wrapper methods consider various subsets of the feature matrix and make a predictive model for each of the subset and find the model for find the highest performing model for the best performing subset. Then they use whatever features were included in that best model, they will obviously be the 2 most significant features as far as affecting y is concerned. So they evaluate subsets of features. I think now it is clear by training and testing. So it is a proper train, test, split, and everything needs to be done, right? Model on them. These models iteratively add or remove features and identify the best performing subset. I think the meaning of that is also clear. And taking into account feature interaction. Now this is very important. Strength of wrapper method is that they take into account feature interaction, while filter methods, which we did earlier, that is the find k best, that does not take into account select k best. That does not take into account interaction of features with each other, right? Okay. Now then let us do this. So here up to this we have done. This is my original data set, top 5 rows. This is my x and y. I am selecting just a subset of columns for simplicity. So think that now this is my original data set, x data, and this is the target column y, right? So print y. If I also print y, then you know that it is the median in house value. So print y, and I will get a vector of values. Each value should be multiplied by $1 lakh or $0.1 million, right? Okay. Now multiply it and you will get the values of y. Now you actually create some model, say linear regression model. So that is why, suppose I am using recursive feature elimination, so I can import that. Again, there is no need to remember. In fact, there is no need to remember anything from here, from sklearn dot. And if you write a dot, then you will get all. For example, that data sets if you want, then sklearn dot data set, and then load fetch load California, that data set is there, right? Similarly, load or import fetch California data set. Similarly, here from sklearn dot and press tab character. So then you are doing what at present? You are doing feature selection. So feature selection, right? So from sklearn dot feature selection, what you have to do is import, and which method you are doing? Recursive feature elimination. So import RFE, okay, and RFE is this. There is a better method that you can see if I again do import and tab, this RFE CV, cross validated RFE. That is always, anything cross validated always gives a more accurate result. But okay, let us take RFE. So I am importing recursive feature elimination method, and I am also importing linear regression model, and then this is a model object, and I am trying to use RFE with estimator is equal to model and n features to select is equal to 2. When I do this, that is all that lengthy discussion which is occurring by just one line of code. What lengthy discussion? That what this line will do, it will create various machine learning estimators, models y1, y2, y3. For y1, it will select x1 only as one feature, beta 0 will always be there, but x1 will be one feature. For y2, it will select x2 as another one feature. For y3, it will select x3 only as the feature. For y4, it will select x1 and x2 both as the feature. For y4, it will select x2 and x3 both as the feature. For y5, it will select x1 and x3 as the feature, and so on. And then it will also select all three as the feature and make multiple linear regression model to predict this response variable, that is y. Okay, so by selecting different subsets of features, multiple linear regression models are created, and whichever model gives the best accuracy, we just take that what features were used in that model. Obviously, they are the most important features, right? Okay, so then this is that whole process which I have described, and two features I want to select out of these three, and then you can use RFE.fit transform. One is my feature matrix. Feature matrix is this, and other is my response vector. Response vector is this, and that will give me XRFE. Okay, if I, for the sake of printing, just print XRFE, you will see that compared to that, this way of printing gives more fruitful information. But let us print. So XRFE gives this kind of thing. It gives idea that two features have been selected, but nothing more is getting clear from this, right? So instead of that, it prints the values of the two features also, 8.3252 and all that. So that is, you can see 8.3252, 6.9. So it has selected first and third feature. But we don't want those values. We just want only the column names. So therefore you write x.columns and RFE.support underscore. And if I print that, then you will see selected features is equal to median income and average rooms. Okay. So out of these three, this time I am getting first and third as the most important features. Previous case gave me median income and house age, first and second as the most important feature, while this gave me this. So you have to choose a very robust feature selection method, because various methods are giving different results. So that's why I said that instead of RFE, you could have chosen RFE CV. Still, this will work in same manner, and selected features in median income and average rooms. Okay, so that first and third features are there. Now, that is, so far we have discussed two categories of feature selection techniques. One is filter methods. There the example was select k best. That is this line. This is the key line. Select k best. Score function is equal to f underscore classif, and k is equal to 2, right? And similarly, this is the key line for RFE. RFE estimator is equal to model, and n features to select is equal to 2. Now we want to take the third category of model, embedded techniques. In embedded techniques, there are multiple techniques. One is called LASSOCV, one is called feature importance with random forest, RF means random forest, and one is feature importance with XGBoost, that is extreme gradient boosting algorithm. But we will not discuss all, we will discuss only LASSOCV. So this method, these embedded methods perform feature selection during the model training process itself, and they are usually specific to given learning algorithms. So that means that the advantage, that is why random forest and XGBoost became so popular, because they are so versatile and powerful. One is that they can work for regression problem also and classification problem also. Then they are robust to outliers, and they are ensemble models, so they are less likely to overfit. Okay, and then there is one more thing, that is they uh, they automatically include embed in themselves the implementation of these two algorithms, or even lasso algorithm also has embedded in itself not only methods to find various metrics like accuracy, precision, and etc., but it also has embedded in itself methods for feature selection, right? But if I am using LASSOCV, then it will the important features which it finds are confined to that algorithm. If I am using random forest, then the features which it finds are confined to random forest. That means that in same for same data, using XGBoost can give different answers, so that is fine. Okay. Now at present we want to do this LASSOCV. Okay. So what this LASSOCV does is something like this. It tries to uh, this is my the general model. First, let me print same California housing data, and let me take that X and Y. Okay, that means mm, here. So this is my original data set having all the features but no response variable. These are my X and Y but with limited number of features. We have been doing this for all previous examples also. Three features I am keeping, just randomly selecting, no logic behind this. And then Y is equal to, that is the response variable is median house value. Okay, and we print them just for the sake of understanding. So this is my response, sorry, feature matrix, and this is my response vector. Okay, feature matrix has 20,640 rows and 3 columns, while response vector has again 20,640 rows but only one column, and these are the values of house which are in multiples of this number, right? Okay, fine. Values of house price which are in multiples of this number. Now we want to find the three most significant features out of this. So these are at present two most significant features. There are at present three features: median income, house age, and average rooms, right? So among them, what are the two most important features for deciding this response variable, that is how median house value? So this time I want to use LASSOCV, which makes one or two coefficients zero. Okay, so one or two coefficients zero means here, for example, I have been told that y is equal to beta 0 plus beta 1 x1 plus beta 2 x2. This is my model. So median income, house age, and average rooms. This is my model. Median house value is equal to this is my model, right? But at present, all three features are considered. I want a simplified model in which suppose the middle feature house age is not significant. So that median house value is equal to beta 1 and beta 3. That term will remain. So Lasso does something. What it does at present, don't worry, because that we are going to discuss in much detail when we do linear regression and various different categories of this linear model. But Lasso does something so that the least important feature, which is contributing the minimum to the accuracy of the model, that feature actually becomes zero. Okay, so then this feature will become zero, and beta this coefficient will become zero. Beta 2 will become zero, and therefore this feature will is as good as not existing in my data set, because in my model x2 may be present while creating the model, but its coefficient itself is zero, so my model does not contain any effect of x2, right? Okay, fine. So that is how to do that by program. Then this is how you will do from sklearn dot linear model, import LASSOCV and import numpy also. Then create a LASSOCV cross-validated model object. So LASSOCV with how many folds? 5-fold cross-validation. Random state is always required, that you know, for reproducibility, and fit that LASSOCV model on my X, capital X, that is my feature matrix, and small y, that is my response vector. So fit LASSOCV model on that feature matrix and response vector, and get the coefficient. So coefficients are LASSOCV dot coefficients. Okay, and even if I want to print those coefficients, then let us print first, so that you will get clearly idea that actually coefficient is not zero, but Lasso has done something so that one coefficient has become zero. Okay, so print coefficient. Then we sort the coefficient in maybe ascending or descending order, and then we select features based on the sorted indices, and corresponding coefficient also we are printing. So if we do that, then these are my coefficients. You can see that Lasso does not make it completely zero, but it is so at present it is not zero, right? That is, here when you print coefficient, then it is not zero. But when you sort it and does it, print them selected features. So at that time you use selected features is equal to x dot columns underscore sorted indices. And when you do that, you will see that only two features are selected and only two coefficients remain. That is, this coefficient remain 1433, and this coefficient remain. The middle coefficient is almost reduced to zero. In fact, this much value also remains just because of certain inaccuracy in floating point calculation because of computers. Otherwise, Lasso will make this exactly zero, this middle coefficient. Okay, and it will keep only first and third coefficient, median income and average rooms, because you will see this is my median income and this is my average room. So if you see how model is simplified, then it is beta 0 y is equal to, or median house value is equal to beta 0 plus beta 1. Beta 0 is this parameter 0.433 plus beta 1 into, that is 0.01669. So that you can see here, yeah, 0.01669. Okay, here it is different. Perhaps this is for some different data set. Okay, no problem. But it is 0.043 and minus the other coefficient is minus 0.0211. Okay, so that are the two coefficients, beta 1 and beta 2. But in short, what is the model now? Y is equal to beta 0 plus beta 1 x1. Even beta 0 seems to have been reduced to 0. So beta 1 x1 plus beta 2 x2. And what is beta 1 and what is beta 2? Beta 3 x3, if I write very clearly, so that you will remember that it is the third parameter which remains. So median income and the average rooms, first column and the third column, they two remain, right? And what is beta 1? Then beta 1 is equal to, forget about these numbers. Let me rub this out completely, or perhaps it will not be removed. Okay, but forget about this coefficient written here. The coefficient for this data set are obtained to be this. Okay, so beta 1 is equal to 0.433 and beta 3 is equal to minus 0.20211. So median house value is equal to 0.433 multiplied by median income plus, sorry, minus 0.0211 multiplied by average number of rooms. Okay, that is what is the simplified model. At least one column I could remove. Now this is about the lasso regression. It has done something so that middle coefficient came out to be nearly zero. In fact, it becomes exactly zero. Now this is a comparative analysis of this three methods. Okay, and this is important because when to use filter method, wrapper method, and embedded method, and when to means while using a particular method, what are its limitations and what are its strengths, that you should be clear. Okay, in short, I am giving one simple key that LASSOCV is often preferred, or if you can't do that, then you select this XGBoost or random forest built-in feature importance method with that. Okay, so use that. Now, definition of the method that we have already done, that in filter method, features are selected based on statistical tests or measures which are independent of any machine learning model. We don't create any model here. Here, more features are selected on the basis of subsets of feature. For each subset of feature, we train machine learning model and we find the best model and the features which are included in the best model that provide the best subset of feature. Embedded method perform feature selection during the model training itself and using built-in feature importance method. Okay. Then example, what filter methods are there? Then correlation, chi-square, mutual information, and variance threshold. What are wrapper method? RSE, recursive feature, forward selection, backward elimination. What are embedded method? Lasso, reach, feature importance from random forest, or gradient boosting. Speed wise, as these are only statistical, no model is created, filter methods, so they are very fast. Wrapper methods are slow because they not only create model but also create multiple different models for each subset of features, right? So they will be slowest. Embedded methods are moderate because they also create model, but they create only one model and feature importance is selected as a part of that model training. Complexity wise, filter methods are easy to implement. Wrapper methods are computationally expensive because multiple iterations and several models have to be built, and these are efficient for high dimensional data provided the model supports feature importance. So Lasso supports and XGBoost supports and random forest supports. Capture or interaction or not, then filter method, though they are simple, their main limitation is they do not capture feature interaction. While wrapper and embedded method, they capture feature information. So from this all discussion up to this, it is clear that embedded method are our preference, right? Because they are efficient also, and at the same time they are having capacity to capture feature information. Overfitting, then filter method are less prone to overfitting, but these wrapper methods, that is forward feature elimination or forward feature addition or reverse backward feature elimination or RSE, recursive feature elimination, they can lead to overfitting. Okay, especially with small data sets. Then these are also less prone to overfitting. Again, that is the reason why we prefer embedded methods. In fact, most of the time we will do feature importance by XGBoost or random forest only, right? Okay. Model dependency. Then the filter methods are statistic based methods, so they are independent of machine learning model. These require certain specific machine learning models, and these also work with model specific algorithms like random forest or Lasso or XGBoost. Scalability, this can scale to high dimensional data. High dimensional means more rows and more columns. Difficult to scale with large number of features due to high computational cost, because this passes through, makes several models for each subset of features, and there it trains each model and then finds the best model. So you can understand that if there are say 100 columns and try to make each subset of features, then that would be very, very difficult, right? This depends on the availability of feature importance mechanisms in the model, right? Now, interpretability wise, these filter methods are easy to interpret as they are directly linked to statistical measure. Then here, their interpretability depends on the what model you use for evaluation, while these methods, embedded methods, are highly interpretable. Okay, so again, that way also, this last column, embedded methods, that is always our preferred method. Then use case is given, in which case you will use this, in which case you will use this, and in which case you will use this, right? Now, this was our discussion about each one example of each feature selection method. So we started our part C this way, that filter methods, and these are various methods. But we discussed only one, K-based features. We did not discuss these three. So we will discuss these three very soon. Then wrapper methods, in which these are various examples, but we discussed only one, RFE. We did not discuss this, so we will discuss them soon. And similarly, in embedded method also, these are the three methods, but we discussed only one. We did not discuss this thing, right? So we are going to discuss them. Whatever methods are left, that we are going to discuss, and we will continue to use our California housing data set only, so that at least understanding of data will not take much time. So very quickly, this is the discussion about those data sets. Okay, and then once that is over, that will take, I think, still two lectures perhaps, or maybe I don't know how many. But then we will start with part D of the chapter, model evaluation and validation techniques. These were the parts of our chapter, right? And still after that, part E, and yes, part E, there the introduction to SQL and library, there the chapter will be over. Just to give an idea, roughly we have covered around 65 to 70% of the chapter. Thank you, and see you in the next lecture.